Hello guys and welcome to another tutorial. We are going to be learning how to burn anything and with a cool trick. So stay tuned and watch the full tutorial. Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop dev, compositing. We will have resources for every type of discipline. So hop in and have fun. I also have a Patreon page where you can support me. I have every single file, I have polls, I have even some tools, guidance, so if you are interested, you may have a look. Thank you. Okay, so let's begin with this tutorial. First of all, I'm of course creating a geometry node and I'm importing this house. This house was downloaded from TouristQuid and I'm going to leave the link down in the description. Firstly, I scaled this down to real size and I just did a little bit of tweaking here and there so I can just move it where I want. I have these set names. The only thing these set names does is to create a primitive class attribute which goes from 0 to 427, which is the amount of pieces this geometry has, and I'm setting the name for name equals to the name, which is called piece, plus the integer class set to a string. That's all I'm doing. Then I'm blasting pieces here, there. I'm blasting everything that I don't need. What do I need? I only need these wood planks. And then I am editing everything, so it's a little bit better for what I need. And doing again the set names, so I can reset these values here and there. I'm polyfilling because there are some open pieces on the geometry. I believe these planks were open. Let me check. No, they weren't, but there were some open geometry, which of course for a Boolean shatter method, we need to have this watertight. I reset the normals just in case. I blasted something there. I matched the size here. And if you watch from the front, I just lowered this a little bit. And then I did the fracture. The fracture is very interesting. Let me show you. So by name, and also on a for each by name, I'm creating a wrangle on points where I grab the B box. So I get the B box of each piece. The B box is the following. If I have a piece going this side, the bounding box would be the box that is surrounding this geometry, and I would assume that the x-axis is bigger than the y-axis, for example, because it's going more there than upwards, right? So this is doing the same. Hey, if my b box in x is bigger than y and is bigger than z, then x is bigger. So the group is x. The same with z, and the y, well, is what remains. Having this into account, I can separate between y being bigger, then z being bigger, and of course x being bigger. Then what I'm doing is to shrink it based on what I want. In this case, if y is bigger, I shrink it on y. I scatter some points. I shatter these. Remember, when you shatter, you always have to append the name because we already have a name. And if we want to see the names being visualized here, we just press Ctrl middle mouse click and then left click on the name, and we will see this is what happens. So if I reset this, it will look something like that. In order to have a reference, you just have to click on Ctrl Shift Alt and drag, and all I'm doing is Ctrl Shift click here and inverting the transformation so it goes back into place. If I don't have this, for example, this is at 1, everything would look like this, but I want it to be stretched because it's supposed to be shards. The same goes for the other methods, but they're going the other way around. Instead of y is going to be z, and if instead of z is going to be x. Once we have everything, this is how it's going to look. Everything is very nice. One thing I forgot to add is that on these set names I had a name or each. The name or each is basically copying my name, and it's just doing, hey, name original is equals to the name. Why do we have this? Because have a look at this. This is my name, and everything is messed up. But if I wanted to remember, where are my original planks, I had to, before doing the fracture, save the name or each. if I change this name reach to color, we will end up seeing that I am having my names, if I do a random from attribute, stored. They are, I mean, we have a name attribute here, and we can corroborate by clicking here. But now we have both things, so we are saving our fractures pieces on the original size. So when we get the fracture, this is basically an object merge of this one. I'm going to assemble them. These are now packed objects. So this is my high resolution geometry. I'm going to set everything on active because I want everything to fall as I start the simulation. And these are the pieces which I'm going to select, which are not going to be activated ever. I decided to use active P equals to 1. Everything that's active P equals to 1 is never ever going to fall in the simulation. Then, if I shrink them, we will have something like this. This is because it's always nice to avoid having collisions when you start the simulation. It's going to be a little bit more optimized. So I do this, or you could stay like that, but I prefer having this shrinked. This is my out RVD, and then I'm going to have another version which is unpacked. This is my RVD unpacked. You will see why I'm using this later on. This is my fracture, of course, which is again the same as this one. I'm going to use constraints. How did I create my constraint? Well, this node is available on my Patreon, but I'm going to show you how I created the wood fractures. Firstly, I'm unpacking it. This is already unpacked, so it's basically the same. But just in case you have an packed RVD, you're going to unpack it. Then you are going to pack it on the left side, so you can have the points. And on the right side, I'm going to scatter some points on my unpacked geometry, which is, of course, this one. Just so I can have some clusters. I'm going to use a wrangle to create the clusters. So my cluster is going to be equals to the point number. The point number being this one. So each number is going to be unique. I'm going to transfer the cluster here to my packed geometry. And then I'm going to do two types of constraints. On the right side, I'm going to unpack everything. I'm going to transfer the cluster. So basically, if I do middle mouse click and click on cluster, we will see that we have this. Of course, the points being the center of these clusters, right? So I can change the seed if I wanted on this scatter, and the cluster would be changing. So having this, I'm going to promote this to primitives. I'm going to add a connectivity node to, well, just in case I don't have a connectivity node. And I'm going to connect by name and also find the clusters. This is very important because I want to only be connected the clusters to each other. This is going to create like a sticky kind of constraints. I'm going to clean everything just in case, you never know. And I'm going to create a wrangle to create the constraints type to all. This is how the constraints like to be called. The constraint name is going to be arbitrary. I'm going to call it hard W because these are going to be hard constraints. The hard constraints can bend a little bit. They have an angle and they have other types of properties different to the glue. The glue are totally stiff and these are not. And the strength is going to be equals to 1. We're not going to use strengths, but it's always nice to have your strengths value declared. Then I'm going to just add a color. On the left side, I'm going to iterate by cluster. So each cluster, basically each of the colors which I had here are going to be one object. For instance, if I do this one, this is a single cluster. Then I'm going to connect adjacent pieces with these values based on name, nothing else. Basically, I'm connecting all the different pieces between each other. I'm going to do a clean just in case. Then I'm going to do the same, but instead of being called hard W, is going to be called glue W. This is going to be another color just to differentiate between each other, and I'm going to delete everything that's, well, these values, because I only need the following. Then then I'm going to do a facet in order to separate each other. Basically, now every single primitive is separated from the previous one, where beforehand, if I do the following, is without the facets, of course, this is not separated, and I want all of them to be separated. I'm going to do a noise. I'm going to do a noise which is going to be called resistance, with just this ramp activated, and this is going to be a way of showing how much resistance the constraints and the geometry has. I'm going to use that inside the solver, and this is how it looks, being the red parts stronger ones and being the blue parts the weakest parts, right? And then I'm going to, this is not disappearing it, but I'm going to just shrink every single primitive. That's why I use the facet, otherwise this was going to happen. So I shrink everything to zero. Now there's one little thing: when you create a constraint with the connected adjacent pieces, you need to have the rest length activated. What's the deal with this is that when you use this property, being shrink it to 0, your rest length should be 0. I didn't like how it looked, so I just disabled this wrangle, which is called rest length equals to 0, because when you have rest lengths more than 0, but obviously your primitives now are set are a single point. We have 2 points here, but it is very small, so it looks like a point. When you have rest length over 0, it's going to expand. I didn't quite have a bad impact in this simulation, so I just disabled it, but it should be turned on, so you can have a look. If you download the file, you can have a look and check how those settings change between each other. Now let's hop into the simulation. The simulation is going to be the hardest part by far, so stay tuned and watch everything that's going on inside here. So we're going to hop in and we're going to visualize something. We usually just work with one single solver, but in this case we're working with 2 solvers. So I'm going to make a small drawing to explain you how this works. So in order to simplify, we have this solver and this solver, which, if you made some simulations before, this is quite easy to comprehend. This is your RBD object. These are the constraints of your RBD objects. This is the network which solves these constraints, and this is everything that has to do with the RBD object, right? When it's activated, when it moves, etc. So why are we having this, which is called rain? Well, the rain is used in this scenario to feed stuff from my RBD packed objects and my constraints. Then it's going to be feeding this new source, and everything from this simulation is going to be affecting my constraints, which then are going to be affecting my geometry, and which this simulation is going to be affecting again my brain. So if you see closely, if we simplify this, it's basically a infinite loop, right? Where the left side affects the right side and the right side affects the left side. So let's begin with this, right? To begin with, all I'm doing here is to hop into the constraint network, which is this one. I'm basically creating my constraints. These are my RBD packed, this is my RBD packed, and this is my fracture. But I'm only going to be using the 3 guys. So if we hop in here, we're going to be calling the constraints, which, if we visualize them, this is how they look. These are my constraints, everything that I created before. This is my RBD packed geometry, and this is my solver, which is going to be affecting my constraints network. The glue constraint relationship, which are glue doubly, only have a strength of 10, and my constraint relationship only has the name here. Let's hop into our subsolver. So what's going on here? Firstly, I'm injecting some points for infection, which I'm going to explain right now, and I'm also injecting my smoke object temperature. Where do I get this? Once we have this Pyro solver with the smoke sparse object, this is my resolution. This is where I want the simulation to be working at. This is my initial source. I'm going to explain right now where I'm getting this information, and this is my extra, which of course I'm going to explain which comes from here. Both things come from here, where this is static and this is dynamic. So let's hop into the brain and see how everything is created. When we hop in, we are going to be having these two things. Firstly, I'm grabbing the unpacked RVD. This is because the fastest method to interpolate points on the surface of a geometry, in my opinion, is with the interpolate points. So if we have the unpacked RVD, we can promote from primitives, which are now the name and the name of each, to points. Why are we doing this? Because when we scatter, if we don't have this, we would be losing the name attribute, for instance. Have a look. Now it's lost, but we need this. And we also need to have this prim number and prim UV attributes. I decided to use this amount of points. Then I'm going to copy my unpacked RVD here, and I'm going to use my points from my RVD. Where did I get this geometry? If we go backwards right here and we select the rigid body solver, we would be looking at this. And let's click here. This is my geometry spreadsheet. So let's go back again. How did I get the geometry? Well, the geometry is get from here. If we open the RVD packed object, we will have an option called geometry. And if we drag it here, this is what's being output from my solver. And these are in fact just points which have a name, and this unpacked geometry has the same name. So we can interpolate, or we can transform the pieces with my simulation again. We could be, instead of having this, we could be unpacking each frame, but unpacking each frame is harder than just transforming the pieces. So that's why I decided to use this method. This has UV and has primitive numbers, which I stored here. And if we interpolate everything, it's going to be stick to the surface. So let's calculate, for example, 18 frames. Okay, so we calculated 18 frames, and let's see what happens with RVD. I believe nothing is going to move, but imagine if something moved, this would be interpolated right here. So these are my points for infection. This is what I'm going to be using for the fire to spread all over the place. I also created BDB from polygons, which is being called collision. This is voxel size, and this is my reshape with an erode in order to make it a little bit smaller. I am not going to be using this, but it's always nice to have a collision. So what I'm going to do next is to manually separate the pieces like so. If we select this and press enter, we will be having an error, but this is how it looks. This is what I selected. I decided to just have a little bit of points based on some shards here. I selected this. This is going to be my initial source of fire. I'm going to set the burn to 1, the temperature to 0.11, the density to 1. Then I'm going to rasterize everything with this being the particle scale multiplying the coverage scale divided by 4. This is only in order to have a relationship. You don't need to be so precise. You can do whatever voxel and particle scale you prefer. I'm using the density, the temperature, the burn, and the velocity, even though here I am not having a velocity, I believe. This is my out initial, and this is what is going to be fed into here, my initial source. As you can see, density, burn, temperature, and velocity, even though I don't have a velocity. On the right side is everything which remains. And this is my low res smoke. Where does my low res smoke comes from? It comes from here. So we are back at the break with Final Mac solver. So what I'm doing here is to create my points from infection, which is, well, of course, this one. And I'm just merging it, and I'm also grabbing the smoke. The smoke is exactly the same. I'm going to click here. I'm going to tick here. And I'm just going to merge, instead of the RVD object, I'm going to go into the smoke sparse, hop in, go into the temperature and just drag it over. Then I'm going to resample this with the volume resample set to 0.5 in order to have a lesser resolution geometry. This is my outlaw resolution. And this is what I'm bringing back with the Control C, going here to my brain and just pasting it here. Inside this solver, what I'm going to be creating is, well, how do I select everything that's been lit? So let's hop in. This is going to be the hardest part of the simulation. So stay tuned, sorry. And these are my points, which is my first input, and this is my temperature, which is the second input. Let's go a 20 frames forward. So this is my smoke, as you can see, it looks very nice. And what's going on here is basically that I'm transferring my temperature to my points, but I'm calling it density in this case. Then I'm multiplying the density. I'm going to show you how it looks. Let me see, this is my density, and if you turn this on, this is how it looks. As you can see, it is moving frame by frame, and it is not storing anything. But everywhere I have a density over a certain threshold, which is very small, I'm going to say, hey, you are on from this moment onwards. This means that if the temperature is bigger than X and well, if the temperature is equal to X, then you are going to be allowed to start adding magnitude. And then I'm just going to load the previous frame, which was of course nothing, and I'm going to transfer the on and the density value. Remember, this doesn't have an on, this doesn't have a density value, but from the previous frame I am remembering what I got here. Then I'm just going to be copying my on value, which is new here. This is old and this is new, and transfer my on value. So I'm updating it, and everywhere my on value is equals to 1 and my density is less than 1, my density is going to be updating to plus 0.1. So basically this is the speed of the simulation, and as you can see, now everything is being stored perfectly here. It is not the same as this one, it is better. This will basically over time expand all over the place. With this, what I'm doing here is to remove everything that's less or everything that's equal to 0 on density. Then I'm going to be setting the fields to, hey, density is equal to the clamp of density from 0 to 1, the burn is equal to the density, the temperature is equal to the density by 0.11. Then I'm going to add some noises on density, on burn, and the temperature, basically with different offsets and different ramps, so everything is different. And then I'm rasterizing this. You can see it is quite noisy, which is very nice. And this is my brain, this is all I need. If I go into here, what I'm doing is exactly the same trick where I'm transferring this, but instead of density is mag, I'm multiplying the mag, I'm initializing the mag, I'm remembering what I got in the previous frame, I'm copying the and I'm accumulating the magnitude to plus 0.03. This is a nice value I got. This will start accumulating, and then I'm stating that the magnitude is equal to 0 each frame, because I want to have a software interpolation with the transfer attribute, which I'm transferring the mag with this distance threshold. So then I'm promoting, well, if I wanted this to be software, I should have increased the blend and the max sample count. Then I'm promoting this to primitives, because remember, these are in fact primitives, but they are shrink to 0. And if my resistance, which I created beforehand, multiplied by my magnitude, is bigger than this threshold in time, basically remember this is accumulating, so it is increasing each frame a little bit. So if I have a noise here, so each frame is increasing, once this reach a certain threshold, it's going to break, and this one is going to stop, and then it's going to break. So this is basically what's going on. And the constraints or the points are going to be starting to break, and the structure is going to start falling. These are my constraints. And something very similar is happening on my on my, what's the name, on my packed RBD. Basically, I'm grabbing the accumulated magnitude, which I got from the previous frame, which is basically this out final magnitude, and I'm transferring it with more samples, a blend, to all my points. These are my points. This is my accumulated points from here. Remember, guys, these are my constraints. And then all I'm doing is, if the magnitude is bigger than this activation time, which is 2 in this case, and remember, guys, they are not active P, basically they are not on the ground, which I selected manually, they are going to be activated because they were active equals to 0 before I started the simulation. And I decided these were the correct numbers, so they're going to be activated first, and then they are going to be breaking all over the place. Well, pretty much that's about it. I have a gravity. I didn't care about the pieces sliding on the floor because this is not the idea of the tutorial. The idea of the tutorial is to do kind of an infection simulation. And then these are the settings for my object, on my sparse object. These are my settings for my simulation. Nothing very fancy, just changing the temperature so it diffuses a little bit, the cooling rate, so it's basically it cools a little bit faster, and the buoyancy is a little bit lower, so it doesn't go up so fast. On flames, I just lower the flame lifespan. I opt the smoke here, and I added the temperature and expansion, so I want to have a little more of temperature and expansion, so it creates like this expanding shape on the smoke. Nothing else. The shape is going to be dissipation 2.1. This is a default. The disturbance is going to have a block size of 0.1 with a max octaves of 4. Nothing else. And the turbulence is, well, pretty much the same. I didn't touch so much the settings. I didn't want to overcomplicate stuff. On advanced, the substeps are going to be set to 2 because it was braking due to the disturbances and the turbulences. And the padding is lowered to 0.1, so I can save some space here and there. That version is going to be the best one, BFECC and clamp. Just do it. It's going to look way better. You can have a test on different simulations. And this is very important. Untick this. Untick the build collision mask. It's going to take so much longer if you don't untick this and you have collisions. But your collisions will and must be set to as before, collision and collision velocity. I didn't inject this here because it was slow regardless, and I didn't need it. But if you decide to have the collisions, do them like so and untick this. It will be a life changer. Then I added a ground for both simulations, and that's about it on the simulation side. The only thing I needed here is to grab my simulation. Let's go to the first frame, and I'm just merging the RVD. Then I'm deleting the geometry but keeping the points, and I'm importing the fields, dragging this one here, and just dop node the smoke object. You need to have these symbols here. And instead of I did a pyro, but instead of rest, I changed for flame. This node is very simple. I just created a convert to BDB, then a BDB vector merge. You don't have to do anything else. And my velocity is going to be using a voxel size of scale multiplied by 2 because I want to lower the resolution of my velocity, which is a vector and saves a lot of space by doing so. And my predim is in general going to be lower on volumes to 16 bits instead of 32, which is also a really nice file size saver. Finally, but not less important, I'm option merging this one and saving the points with the file cache, and the same with the fire with the file cache. But how are we going to save this? Well, in order to save this at the same time, we got to go into a RobNet, do a fetch, and fetch the file cache renders. These are the renders. Do this one and this one. And the way this has to be set up is with a merge. You're going to click on render. But first, make sure this is frame by frame. Copy the settings right here. This will allow us to save each frame to different file caches. On this side, I'm going to load in the RBD high, which was this one, which is this one, which is not shrink. And then I'm going to transform the pieces with this one, with these transform pieces. Then I'm going to unpack everything. And this is for stage. I'm going to rename the names to my name originals. Otherwise, I will have too many pieces and it will be quite slow to load in. Plus, I would like to have only the full planks as a singular piece. Then I'm going to have this fire. This is an optional address. The people in the Patreon can have a look at this. I'm not going to show this on this tutorial because I didn't quite like the approach I created, but it could work in some scenarios. Then I'm just outputting the fire. And what I'm doing here is to grab the pieces which I created plus the fire, which a Pyro bake. In this case, let's go to the frame 1053. This is my fire. As you can see, I created some nice curves so you can have more contrast in some places. As you can see, this is my threshold on source range, which I'm copying the relative reference here. You can see they are both the same. You can, of course, compute it. You can do whatever you want here. This is the look you deserve or you want to look for. And the sculpture, I just turn this on and set this to 11. This is without, and this is with. It's pretty much the same. And smoke, the only thing it changed is the shadow density. And remember, guys, here we have a Pyro shader. So let's copy the Pyro shader and let's go move to stage. When we move to stage, we're going to do a little bit of triggering, but not much. So I'm grabbing the sub import on the wood, which I just grab the wood. Then I grab the fire. I also made a grid, and I grabbed with the import cameras, the camera 2. I merged all of them, and inside here I created a Martial X, which is basically a standard surface with a roughness of 0.4. What I'm doing here is to select the house, the grid, and give it the house material. The same is going to happen to my wood house. As you can see, all I'm doing here is to say, hey, you are my house, and I'm also grabbing the wood from the house. But it could just work out like this, probably. If we go into the materials, this is going to be looking. Sometimes it can fail when I add a dome light. This should be working, I believe. If I move from animation to scene view, there it is. As you can see, if I add the wood and all the pieces, each is exactly the same. So just wood should work. And then remember, I copied the material and pasting the material here, and I'm calling the fire doing exactly the same. Just with fire is going to be working. On the camera settings, on the dome light settings, I'm just grabbing a HDRI with an intensity of 0.32. I like how this looks, so I'm keeping this. And then camera render settings, what I'm doing here to make it look a little bit better is to have the primary samples on 16, every limits to 10, and the camera is set to 0.2. I'm not changing everything else, and on the USD RAW, I'm just rendering to disk. I didn't do anything else. So this was the full tutorial. Hello guys, and thank you for staying here. Please don't hesitate to leave a comment, to subscribe, to join my Discord channel where we will be learning a lot. See ya.